Video on the channel. In today's video we're going to be continuing off where we left off from last video. So we're still on Math Methods External Exam Paper 1 2024. So this is pretty much just part 3. We're going to be covering question 18 and question 19. Okay, because I think they needed their own little parts, and plus the other video would have been too long. Just like the previous videos, if you have any questions about any of these questions at all, or any even part of it, try and timestamp when you have your question and pretty much which one it's referring to, if it's like a line of working or a question itself. But otherwise, let's get straight into it. Okay, so question 18, as we can see here, the diagram shows the dimensions of a large storage container that has a rectangular prism. The angle ABC is 60 degrees. A person requires a container that is at least 4 meters in height. Okay. Make a justified decision about whether the storage container meets the person's requirements. Okay, so at the moment we're just looking at this guy here, but we don't know really much about it. The only thing we know about it is that base bit there. So you can see there that we have 4 and 3 here, but they haven't actually given us the height here. Okay, and we need to know if it is at least 4 meters high, pretty much. Okay, now they've also given us this. ABC is 60 degrees. So if you don't know how to find where that angle is, pretty much what that's referring to is the vertices of each bit of the triangle. So that's referring to that guy there. That, I'll just highlight each of them. That is referring to that. And that is referring to that there. So the angle between them is 60 degrees here. Now obviously they've labeled a bit there, but if you don't know how to read it like that, that's how you do it. Okay. So we know that, and we know that. Okay. Well, first of all, what we want to do is pretty much start making this triangle here, the ABC triangle. Okay, so B, A, and C. Now, we don't know any of the side lengths here, but we know that's 60 degrees. Now remember, they want us to use stuff we've learnt from the syllabus, okay? So they probably want us to use the cosine rule, the sine rule, or just some general trigonometry here at the moment. Now what we can do is we can actually work out what this side is here, okay? Because if we were looking from the top perspective, we know that side and we know that side. So technically we're looking at a triangle where we have, that's the pink bit there, that's 4 and that's 3. So to find that, we just have to use Pythagoras' theorem. So that side there I'm just going to call x. So x squared is equal to 3 squared plus 4 squared. Therefore x will be the square root of each of these guys squared. So pretty much what you'll get there is square root of 9 plus 16, which gives you the square root of 25. So therefore that side there is 5. We can work that out there, okay? Now I'm just going to rub that stuff out. I'll leave that working there on the side there, that way you can refer to it, but we know that's 5 now. Okay, great. We still have no idea what this is, and we don't know what that is, okay? Now, how I know to use a triangle like this is they wouldn't have given this triangle here in the first place if we didn't have to use it. What we can do here is we can get an expression for this. Oh, if I can highlight properly. We can get an expression for this bit here in terms of h. And we can also get an expression for, I'll use the blue, this expression here in terms of h. Because we can just use Pythagoras' theorem there as well. So here, we don't know what the height is, but we can call it just h in the meantime. So let's call that h. That's also, let's use a different color. That's also h. So if I'm looking at this triangle here, I've got the triangle h, 4, and that bit there is the green bit. Okay? So what that means is that side there has to be that squared plus that squared or square root. So that's the square root of h squared plus 4 squared. So we know what that is in terms of the unknown and that guy there, because that's a right angle triangle. And you can do the same thing there with that blue triangle. So if we're looking at that blue triangle, we have this as the blue bit there. That is 3 and that is h. Meaning that's going to be the square root of 3 squared plus h squared. Alrighty, now we're getting somewhere. We know what the green bit and the blue bit is. So let's just draw this triangle down here. So that's 60 degrees. That's 5. I've kind of botched the triangle a little bit. That's okay. Hang on, let me just try that again. You can make fun of me all you want, but if you were doing this in an exam, you probably wouldn't be up to this bit here. But let's take a look at this bit here. Okay, there we go. So we got 60, and we have 5 there. And what was the green bit? The green bit was that guy, h squared plus 4 squared. We'll work out what those guys are very shortly. And this was 3 squared plus h squared. Okay, perfect. This is good for us because we can combine all this information pretty much using the cosine rule. Because here, the reason why I know it's the cosine rule, not the sine rule, is because we don't have any pairs. Well, we have one pair, but we don't have another pair, and we don't need to find another pair. So the best thing here I would recommend is just combining all this information into one quote-unquote formula, okay? Now, what I would do personally is, because on your formula sheet, you're given the sine rule, the cosine rule like this, where you have C as that guy there, okay? Now, that's referring to if you have the triangle like this, where that's big C, that's little c, that's A, and that's B. In our situation, this is like your big C here. That's like your little c, etc. Okay? So even though the triangle has it labeled ABC here, they've done that on purpose to not to confuse you when you're going here. So technically the rule C squared equals A squared plus B squared minus 2AB cos C, that works when your triangle looks like this. However, our triangle is labeled differently. Now, what I encourage you to do in an exam, you can change the cosine rule to match your actual situation up here. Or you can just take this triangle, put it down here, put those informations in, and just relabel it like this. Either one is fine, okay? So now looking at this triangle here, even though this C technically isn't the C from the diagram, in my reference frame here it is, okay? Otherwise, you'd have to write the whole thing like A squared equals C squared plus B squared minus 2 C, B, cos A. And a lot of you won't know how to do that well, okay? That's just the brutal truth. So what's going to help you best here is just to alright, write a brand new triangle and label it according to the rule in your formula sheet, rather than changing the formula, okay? So here, looking at this triangle here, also if you have any questions about what I just said, try and leave something in the comments. That'll be the best way I can answer it. And that highlighting is butched. Let's try that again. So that is that angle there. That, geez, not happy today. Anyway, that is that guy there. Let's use a different color. That, we can call that A in this case here, which means that will also be it. And then, didn't really want to use red, but that will be the B in this case here. That's kind of cooked the writing there. Hopefully you can still see that. So if we sub all this information in, we're going to have, let's use a different color. Let's go back with the blue. Now here, this 3 squared is 9, so that's 9 plus h squared. Likewise here, 4 squared is 16, so that's the same as the square root of h squared plus 16. Hopefully we are all comfortable with that there. Chuck this guy in. So here it's going to be the square root of 9 plus h squared. All of that's getting squared. The A I've said is 5 in this case here, so 5 squared, plus this guy here getting all squared, so square root of h squared plus 4, not 4, I nearly wrote the wrong thing, 16 all squared, minus 2 times by 5 times by square root of h squared plus 16 cos of 60. Now, the reason why we want to do this, we're trying to figure out what h is, right, in order to meet this person's parameters, okay? We now have an expression in terms of h. It's an ugly expression, but still expression nonetheless. I don't think there's any other way to do it like this. I think this would be the only way. Obviously, this is a pretty hard question, but it is definitely solvable here, okay? Alright. So, first of all, this is a non-calc exam, so we've got to work this out without a calculator. So that's where you're going to need this guy here. So you would have remembered this triangle hopefully from year 11. You should have actually been looking at it in year 12 as well. We can use this to work out all sorts of things here, okay? So cos is adjacent over hypotenuse. So go to 60 and go the adjacent, the hypotenuse. What that means is cos of 60 degrees is equal to a half, okay? So all of a sudden we've worked out what that is. Now, you can see each of these guys here have a square root and a square. We can cancel those guys out. So that will just turn into 9 plus h squared. 5 squared is 25, so I'm going to write 25. I'm going to rub this guy out now because it's going to get in the way, but if you need that, just rewind the video. Okay, so 25, that will cancel out with that square root, so plus h squared plus 16. Now here I'm just going to write as minus 2 times by 5 times by square root h squared plus 16 times by, and we just worked out was a half. Okay, alright, let's rub this stuff out now. I don't need it. Obviously show all your working. Don't do what I'm doing and writing outside the box. Anyway, now let's try and simplify this. Here, I can clearly see I have a 2 multiplying this and multiplying a half. Those guys can cancel out because timesing by 2 and timesing by a half are the opposite thing. What I can also see here is basically I've got a h squared plussing on both sides. So that can cancel out with that guy there. So what I'm left with at the moment is 9 equals 25 plus 16 minus 5 times by square root h squared plus 16. That's going to be quite easy to solve, okay? Alright, so here, move the 25 and the 16 to the other side. So in this case here, we have 9 minus 25 minus 16 equals negative 5 square root h squared plus 16. Alright, what we're going to do now is work out what that is, okay? So 9 minus 25 minus 16 is going to be negative 32. Fingers crossed, okay? Alrighty, I should probably write this down here. Let's move it down. Negative 32 equals negative 5 square root h squared plus 16. Okay, divide both sides by negative 1. So 32 equals 5 square root h squared plus 16. Divide by 5. You could have done that all in one go, but I like to break up the steps for you guys. Now remember, in the comment section, a lot of people comment, oh, why are you taking so slow on the steps? Well, that's because not everyone can take the really big steps in their math. So I try and show as much as I can without going a bit like year 10 level, okay? All right, so here, now what we're going to do is go get rid of that square root. So we have to square both sides. So pretty much it'll be 32 over 5 all squared gives you h squared plus 16. We're going to move the 16 to the other side. Okay, now this is where it's going to get a little bit tricky, okay? So this will distinguish who gets full marks and who doesn't get full mark. This is a non-calc exam, okay? How are we going to work out what h is from this without plugging into a calculator? Well, all we need to know is that it's at least 4 meters high. So keep that in consideration. All we need to do is prove that we know h is bigger than 4. Okay, so here what we can do is, all right, let's go 32 divide by 5, okay? That's going to be probably the trickiest bit here to work out. So here, if we did 30 divided by 5, that would give you 6. And we know 2 over 5, what's that? Oh, I'm having a mind blank there. Like 2 over 5 as a fraction. Geez, this is actually really bad, 2 over 5. Or fifth is 0.2. A fifth is 0.2, so 2/5 would be 0.4. So here, this is basically 6 plus 0.4, because 2 over 5 is 0.4, because a fifth has to be 0.2. Okay, hopefully everyone's good how I got that roughly. Now, let's just say, so 32 over 5 is 6.4 roughly, okay? Let's go here. Rub that out. So this is what we've got at the moment. So we've got now, if I want to get h by itself, I'd have to square root the whole thing. So h is the square root of all this. So I'm just going to write like this for now. Minus 16. Okay, so this is what we know. So square root 6.4 squared minus 16. Okay. Now what I'm going to do is a bit of a little trick here, okay? I'm going to say 6.4 is approximately 6, because I'm not going to work out what 6.4 squared is, okay? That'll be a bit ridiculous here, because remember, you are under time pressure here, okay? So 6.4 is approximately 6, give or take, etc. You might hate my math, you might like it, okay? 6 squared is 36. Now, the only reason I want to know that is pretty much, is this going to be a decent number here? So here, h is going to be approximately square root of 36 minus 16. Now this is making h smaller than what it actually is, because I know for a fact 6.4 squared is going to be larger than 6 squared, okay? This gives us that h is the square root of 20. Now, 4 is the same as the square root of 16. And I know for a fact the square root of 20 is larger than the square root of 16, which therefore implies that h has to be bigger than 4. Because that is approximately h, and that is definitely 4. So that's how we can prove that statement there, without getting the nitty-gritty stuff there, okay? Alrighty. So if you have any questions, I'm sure there'll be some questions about this one here. Leave it in the comments. I'll try my best to answer it. But otherwise, let's move on to the next one, because the next one's pretty tricky. Okay. Now this one here took me a bit. I got it wrong first 2 times, but I think I've got a good understanding of it now to explain to you guys here. So a permanent ice glacier is in a valley in New Zealand. Okay. Due to the temperature changes of the season each year, the glacier expands for 6 months and recedes for 6 months. So basically it gets bigger and it gets smaller. The changing distance of a point on the front edge of the glacier to a car park can be modeled by a sine function. Okay, during the colder months, when the glacier expands, the front edge of the glacier moves to within 270 meters of the car park. However, in the warmer months, when the glacier recedes, the front edge moves to a maximum distance of 280 meters away from the car park. So if it's basically what I'm reading so far from this, is it's isolating, no, not isolating, it's cycling between distances. So think sine, maybe cos curve at the moment, okay? The erosion effects of the glacier on the ground are of the most interest to geologists when the absolute value of the acceleration of the front edge is greater than this number here, meters per month squared. Okay, so this is where we'll start to lose a lot of people here, okay? All they're saying is they want to know, this is just a number here. It looks scary, but this is just a number. They want to know when it's greater than this acceleration. So the acceleration is talking about when it expands and when it recedes. That's what it's referring to, okay? During these times, a team of geologists sets up a camp nearby to perform fieldwork. Whenever the acceleration is less than this, the geologist will have to leave the camp. The following claim is made. The geologist will spend a total between 7 to 8 months at the camp site each calendar year. Evaluate the reasonableness of the claim. Okay. This is a mouthful, definitely worth 6 marks, maybe even 7. Okay. Now, after your exam, when you get to this question, you're going to have a lot of exam fatigue. A lot of people won't get this one right. This is how we break this down. Now, obviously, I'm doing it in the comfort of my own home, so I've had a bit more than a couple minutes to look at this guy here. But this is how I would tackle it, okay? So as soon as you see this and this, I want you to think sine and cos, because over time it's going to be this big distance, that small distance, this big distance, that small distance. That's going to be a sine or a cos graph, okay? Now I would go with a sine, just assuming it's going to have a baseline. So here, if it is going to be a sine curve, it's going to go up to 280, okay? Then it's going to go back down, and then it's going to go down to 270. We can find that midway point. So halfway between that would be 275, meaning that distance there is 5, that distance there is 5. So if we're assuming it's a sine curve, now we have to say this is a function of time because we're talking about distance and time, okay? So here, let's just call this f of t, where this is the distance at a time from the car park, okay? So here, let's just say f of t, the distance from the car park is multiplied by the amplitude, sine, whatever that period will be, times t, plus that midway point. We already know 2 of these terms. We know that guy there is that, and we know that midway point is that. We just need to work out what this would be, okay? So how compressed this is over a year. Now remember, this is over a whole year, okay? So here, when we're looking at this factor here, this is the period distance, okay? Now, you might not remember this in year 12, but you definitely would have learnt this in year 11. Period distance is pretty much 2 pi divided by over that whole distance. Now here, because it's over a year and they're using months, that number on the bottom is going to be 12. So the period distance will have to be pi over 6. So this is what we know. The distance of the glacier at a moment in time is 5 sine pi over 6 t plus 275. Now, what's good about this at the moment? Well, we've got an equation. It's a start, okay? So probably gotten a couple marks here, okay? Now here, the whole thing about acceleration. Now, you have done motion. You should have done motion in year 12. Basically, this is distance, right? If I were to differentiate this, it will give me the velocity of the glacier. And if I were to differentiate that again, it would give you the acceleration. So the acceleration is your second derivative. So all we have to do is differentiate that. So even if you don't know what to do next, if you differentiate that, you're probably going to get some marks. So let's write down here. So f of t equals, what was it? 5 sine pi over 6 t plus 275. Alrighty. Now, what have they said in the question now? So, we should probably differentiate it. Okay, so let's differentiate this. So if we're differentiating this, you're going to be using chain rule. Oh, Hilo's not liking me today. You're going to use chain rule on this guy here. That's just going to disappear to nothing. Okay, so this will turn into, differentiate the inside. So bring out the pi over 6. So pi over 6 times by 5. And the sign turns into cos. So cos pi over 6t. Then we're going to differentiate that again. So do the same thing, do chain rule on this guy here. So cos will turn to negative sign and bring out that pi over 6. So it's going to be pi over 6 times by pi over 6 times by minus 5 sine pi over 6t. Which gives us, if we simplify that a little bit more, pi squared, well, negative 5 pi squared, 6 times 6 is 36 sine pi over 6t. Okay. Believe it or not, that wasn't the tricky bit. This next bit was. So here they're saying the erosion effects of the glacier on the ground are at most interested the geologists when the absolute value of the acceleration of the front edge is greater than this here. Okay? Now, only half people will get half, well, most people only get half of this right, because when they say absolute value, acceleration can be negative. So you want to know when this is going to be bigger or equal to this guy here, and the negative version of that. So basically you want to know, alright, when this, what was the number? I can remember that. When this is that, when it's greater than that, they set up camp. When it's less than that, they leave. Okay. So here what we're going to know is when this curve is equal to both this guy and when it's equal to the negative version of that. And then we have to work out the time in between. I know. Okay. Alrighty. Again, if you have any questions about this so far, leave something in the comments, timestamp it, but let's keep going, okay? Because we've still got a bit to go. Okay. So let's do the first one. So, we've got f double dash of t, it was minus 5 pi squared. I've got it written next to me, I can just write off that. So just so you guys know, I've solved it before, I've got it right next to me, so I'm not cheating or anything, I'm just using my previous working here, okay? Okay, so we want to know when this is equal to the positive one, so 5 pi squared root 3 over 72 is equal to this. And then we've got to start solving it. Now they picked the numbers quite on purpose here, because remember this is still non-calc. Alright, so what we're doing first is when we're solving this equation here at the moment, is basically we've got to get the t by itself. That's still our main goal, okay? So here, if I divided both sides by 5, I can clearly see I can cancel out the 5 there. I can cancel out the pi squared. And 72 is exactly double 36. So I can replace that with 1, and I can replace that with 2. So here, and I can divide by the negative as well. So here, what you'll get is negative square root of 3 over 2, perfectly, okay, is equal to this guy here. Alright, now what we've got to do is we've got to work out that interval pretty much, okay? So here, if I want to get the t by itself, I have to sine inverse this guy here. So here, I'm going to sine inverse negative root 3 over 2. What this is asking is when does the sine curve equal negative root 3 over 2? So our sine curve looks like this. Now negative root 3 over 2 is down here. So when it intersects, it's actually going to be there. Okay. So here, when you're sine inversing negative root 3 over 2, it's the same as just negative 1 sine inverse of root 3 over 2. Now how do you work that with a calculator? You need this triangle here. Your 60, 30, root 3, 1, 2 triangle. Now there's also the 45, 45 one as well. But in this case here we don't need it. Okay. So here sine is opposite over hypotenuse. So what we go here is just label where those numbers are appearing in the triangle. Opposite hypotenuse. Therefore it's 60 degrees. So this one is going to be negative 60 degrees, which in radians is negative pi over 3. Okay, which makes sense. So that's negative pi over 3. We're interested in these guys here because we're looking at positive time. Okay, now this distance here is the same as that distance there and the same as that distance there. So this guy here would be, so that's pi, and that's 2 pi. I just realized I'm going to have to go on to the next page. Sorry guys, just going to move our working down here. So we've got those guys there. So this solution is going to be pi plus that distance, which is pi over 3. And this guy here is going to be 2 pi minus pi over 3. So at the moment we've got, I'm just going to write that working down here, minus root 3 over 2 equals sine pi t over 6. Sine inverse that, so we get pi 6 equals, so the first solution is pi plus pi over 3, 2 pi minus pi over 3. So now let's work what those guys are. So 1 plus a third is going to be, what's that, 4 thirds, so 4 pi over 3. And 2 minus a third, so 2 is the same as 6 over 3. So 6 minus 1 is going to be 5 pi over 3. Fingers crossed I got that one correct. If not, we'll have to come back to that. Now what I'm going to do is get the t by itself. So I'm going to multiply both of these guys by the opposite of this guy here, aka 6 over pi. Okay. So my t value, so t is going to be, the first one here is that times by that. And this one is that times by that. And we can see in each of them, cancel out the pi's. So here you have 4 times by 6. So 4 times by 6 gives you 24. 24 divided by 3 would give you 8. So this first one here is 8. This one here, 5 times by 6 gives you 30. 30 divided by 3 gives you 10. Okay, so t equals 8 and t equals 10. Okay, so that means the distance of time between those guys is only 2 months. Okay, so at the moment that claim is not reasonable when they said what's it called, 7 to 8 months. Now a lot of people would just stop there. You've got to do the negative one as well. Okay, so we've got to know, all right, when does it equal the negative version of that guy now, okay? Because we've got to compare that as well, because negative acceleration can be negative as well. I'm going to go back to this one. So here we've got to make it equal to this one now. So negative 5 pi squared root 3 over 72 equals this guy here. And I'm just going to do the exact same thing here, okay? Pi t over 6. Alright, so here you can see we can cancel that. That's a 2, and that's a 1. So again, you're going to get that root 3 over 2. Oh, what's going on there? So root 3 over 2 equals sine pi t over 6. Okay, so going back here. So when you sine inverse root 3 over 2, that's going to give you that 60 degrees like we worked out before, which was that pi over 3, which is that first solution there. And we'll include that one here, but we also need this guy here for that length of time. So this solution is pi over 3, and this solution is pi minus pi over 3, because just like with the other one, that distance is the same as that distance there. Okay, so that point there is pi minus pi over 3, because that point there is pi, and that's where we're looking here. So we've got pi t over 6 equals pi over 3, and pi minus pi over 3 is 2 pi over 3. Multiply both sides by 6 over pi, so t is going to be pi over 3 times by 6 over pi, 2 pi over 3 times by 6 over pi. Cancel, cancel. So t equals 2. And here, what's that give you? 4. Okay. And the distance between these guys here is still going to be, oh, is it? Yeah, okay. So here you get 2 months there, and then 4 months or 2 months there. But pretty much neither of them will give you 7 to 8 months. So the claim is not reasonable. Okay. I'm glad I left this to a third video because both of these questions took a bit of time to work out here, okay? Anyway, if you have any questions about any of these ones here, leave something in the comments. But otherwise, I'll see you in the next exam video. See ya.